everybody, and welcome to the second part of API testing video series in Web Pentesting and Python course. In this video, we are going to focus on API Reconnaissance. And by Reconnaissance, we mean gathering as much information as possible about the available APIs and their methods in a web application. At this point, you should already understand what an API is and how to send different types of requests such as posts, gets, puts, and so on. If you are not familiar with APIs, I recommend watching the previous video in this series first. As you saw in the previous video, one of the most important attack surfaces in a web application could be its APIs. To identify the available APIs, we can simply browse the application and look for API endpoints in the HTML or JavaScript codes. These endpoints are places where the application sends requests to the server for specific resources. The API paths usually include the word API that makes them easier to find. For each API, we can attempt to identify the following details: the required and optional parameters in input data, the types of requests that API accepts, and if there are rate limits or authentication and authorization mechanisms for this API. Since APIs are to be used by other developers, they are usually documented so that developers know how to use and interact with them. This documentation can be in both human-readable and machine-readable formats. Human-readable documentation contains information about how to use API, some examples, and usage scenarios. Machine-readable documentation is often written in structured formats like JSON or XML. API documentation could be publicly available, especially when API is intended to be used by external developers. So it could be one of the best resources to gather information about the APIs. Even when the API documentation is not publicly available, you are still able to locate APIs by browsing the app and analyzing HTML and JavaScript codes and find API endpoints. You can do this manually, or you can use some tools. As suggested by PortSwigger, you can use Burp Scanner that's available in Burp Suite Professional Edition. If you have Burp Suite Community Edition, don't worry. You can write your own Python script to crawl the app and locate APIs. And we will do this in this video after solving the next lab, because I want to show you how to find APIs manually. So let's jump to the first lab in this learning path. In this lab, we have to find the available API documentation and use it to delete a user named Carlos. We can also log in with a user named Winner with password Peter. To solve this lab, we have to know what API documentation is, how API may be useful to attacker, and how to discover API documentation. So we are ready to solve the lab. Let's access the lab. There it is. I usually use Burp Suite browser to browse the application and at the same time intercept the traffic. So I copy the URL and paste it here. There you go. You see, this is an online shop with a list of products. You can go to the details for each product, and it is a static page containing some information. I can go to my account and log in as Winner with password Peter. After login, there is a change email address page, but before moving forward, I like to see the HTTP history here. And you see there is a list of GET requests to different pages, and there is a POST request for logging in. I cannot find something interesting here because the target of this lab is to delete a user account, and we have to find API endpoints that manipulate users. So this change email address could be an interesting starting point. I changed the email address into abctest.com and it changes it. Here we have a patch request to API user Winner. That is for sure an API endpoint, and you see the information about this request. I send it to the repeater to work more with this request. First of all, I like to see if I can use this patch request to change Carlos's email address. So I replace winner with Carlos, send it. Okay, it says forbidden. So there is some access control mechanisms for patch requests. But let's see if I can get Carlos's information. And in response, it returns Carlos's email address. So there's no access control for getting information about a user. Now I try to find any other API in this path, so I remove the username. There's no API here. I remove user and I get HTTP 302 error because this path is not valid. I add a slash here, send it, and now I receive something. You know, in many web platforms, two paths with or without a trailing slash are treated as two different endpoints. So here I have a HTTP response and I can view it in my browser. And this is API documentation we were looking for. You can see here endpoints and possible request method. We already knew about get and patch method, but you see here that delete is also possible. And you can see here the input parameters for each endpoint. When I click on delete method, you see that this documentation is interactive. So I can enter Carlos here to delete it. And the user is deleted and the lab is solved. And we can do the same manually. Let's go back to the previous API and get winner information. There is a typo here. Okay. Now I send a different type of request to see the server's reaction. And in response, I get an error message which tells me which request methods are allowed. So I can send a delete request to API user Carlos to delete this user. And of course I get an error message because this user is already deleted. Another way to find APIs when documentation is not available is by inspecting the HTML codes. So let's go back to this change email page. I inspect update email button. And here there's a form that onSubmit calls change email function, and this change email function is defined in this JavaScript code. You can do the same by analyzing the intercepted HTTP responses to our request. Here we have the GET request to my account, and in response you can see the HTML code. And here is the form with action API user that onSubmit calls change email JavaScript function. Let's copy the address of this JavaScript code and browse it. Here is the change email function in this JavaScript code that first extracts username and email from form data and then sends a patch request using fetch function to this endpoint address. And to create the address, it uses the form action, which was API user, and the username. So this address is dynamically generated. And in the body of this request, it sends email address in JSON format. So we should keep in mind that some of the paths could be dynamically generated. Now let's create a simple crawler to find APIs automatically. Here you can see my own crawler that is available in my GitHub repository, and I will put the link in the description of this video. You see, I have used libraries like Request to send HTTP requests, Beautiful Soup to analyze the HTTP responses. I use regular expression to define URL patterns, and I use URL-lib to parse and work with URLs. First of all, I create a session to keep login cookies and headers, because in many applications there is a login page and many of the URLs require authentication to be accessible. So first I log into the application and then start crawling using the created session. To crawl, I need a start URL, that is usually the URL of the first page in the application. And I use URL parser to extract the main domain from start URL and then use this domain to filter detected URLs that are not related to this application. Now let's go to VS Code and see more details. Here is the login function. You should put your login URL here, and then it uses the session object to send a GET request to the login URL. And the reason for sending a GET request instead of a POST one is to achieve a CSRF token. CSRF tokens are randomly generated unique strings that the server puts in HTML forms in responses to GET requests. These tokens are used to prevent CSRF attacks. So when we want to send a POST request as an action of a form, the payload should contain the relevant CSRF token. Here is the payload for POST request. I should replace user and pass with my own username and password, winner and Peter. And the CSRF value will be dynamically set. Then I use the same session object to send the POST request, receive the response, and I print the response code to make sure that login was successful. Here is the crawl function. It uses the same session object to send GET requests to different URLs. This function is recursive, and there is a list of visited URLs, and if the current URL is in this list, it returns. Otherwise, it adds the URL to this list and sends a GET request. Then it analyzes the response header to check the content type. According to the content type, it extracts the URL from the response text. For example, when the content type is JavaScript, it calls the extract URLs from text function, and this function searches for the patterns of URL in the JavaScript code. Then it checks if content type is something other than HTML to escape non-HTML contents that usually do not have URL. After that, we create a beautiful soup object that parses HTML code in the response text to find different elements in it. For example, for all script tags with non-empty source attribute, we extract the source value, concat it to the current URL, and create a complete URL. Then we crawl the extracted URL if it belongs to the domain of our application. Also, for all A tags that contain a link, we extract the link, concat it to the current URL, and if again it belongs to the domain of the target application, we crawl it. And finally, after parsing all HTML tags, we scan the raw HTML text for any URLs inside the page content, even if they are not part of a normal HTML tag. Now let's go inside this function that extracts URLs from text. As you see, this function uses a regex to search for URL patterns in the text. And this regex is defined here to find absolute and relative URLs. Absolute URLs begin with HTTP or HTTPS, and relative URLs begin with a slash. And here are two examples of each one. Then each detected URL is joined to the base URL using URL join function. And this function is smart enough not to join absolute URLs. Finally, if a URL contains any of these words, it will be added to the list of detected API endpoints. And the reason for searching v1 and v2 in a URL is that by upgrading a web application, the APIs might be addressed through their versions. And in the final attempt to detect API endpoints, we brute force API addresses. And we do this by adding some paths to the base URL. And these paths are selected from this list that contains common words that are used in API paths. Then we send a GET request to each created URL using the same session object, and if in response we receive anything other than 400 error, it means that the URL is active and the URL is added to the detected API endpoints. Now I use my crawler to find API endpoints in this lab. First, I have to copy the URL of starting page and paste it here as the start URL. Also, I have to put the login URL here. Username and password is already set, so let me run it. And it gives me an error because it could not find CSRF token. I think the session is expired and I could not receive the response of my HTTP GET request. So I have to access the lab again to create a new lab for me, and then copy the URL, paste it here, and run the app. As you see, it first logs in and then starts crawling. It crawls various URLs and visits JavaScript codes like change email JavaScript code. It visits all the URLs for different products and then starts API brute forcing. And here is the list of discovered API endpoints. You see that the crawler currently cannot detect API endpoints with dynamic URLs. So as an exercise, you can extend it to detect endpoints with addresses that contain dynamic parameters or patterns. Also, you can extend it to discover possible request method in each API endpoint. As the final point, I like to go back to our simple API app. I have prepared an API document HTML code for this application that we can view it in our browser. Here there is the list of endpoints with possible request methods, how to send the request, and what are the expected responses. Also, there is a simple Python usage example and some notes. And if you remember, this application is vulnerable. The question here is what we can do to make this application and the one in the lab secure. Does removing the documentation or making them private make the application secure? I believe not. When you make an API endpoint publicly available, removing the documentation or making them private just makes it longer for an attacker to find the API. The main reason is something else. These API endpoints have no access control, and we have to implement it in our application. And that's what we are going to do in next video. So stay with us. Thank you for watching.